So now we're going to use derivatives in an application, namely to find the slopes of tangent and normalize to a graph at a particular point. I'll tell you what a normal line is later, but now, for now, you know that the derivative is the slope of the tangent line to a curve at a certain point. Okay, so if we want to find the equation of a tangent line to a graph, what do we do? Okay, so first we have to, first step is to take the derivative of the function to find its first derivative, and then we're going to plug in to the first derivative the point at which we want to find the slope. And then using the slope and using the point, we can find the equation for a line, right? Using the formula, we're going to use the point-slope formula to find the equation of the line. And the point-slope formula, if you don't remember, is this: y minus y1 equals m times x minus x1. Alright, so let's start off with an example. Y is equal to x cubed minus x all over the square root of 8x squared plus 1. And I want you to find the equation of the tangent line to the point 1, 0. That's really messy. But I want you to find the equation of the tangent line. Alright, so we have to take the first derivative. Okay, so we have to use the chain rule in this case, and we also have to use the quotient rule. Let's start. So it's going to be the bottom times the derivative of the top, 3x squared minus 1, okay, minus top times the derivative of bottom. Okay, so we see that we have the square root of something. So the derivative of the square root of something is going to be 1 over 2 square root of that something times the derivative of that something. So over 2/8. That's the chain rule. Right, so now I have to apply the chain rule. So I took the derivative of the outer layer. Now I have to take the derivative of the inner layer, which is going to be 16x. Okay, and all over the bottom squared. 8x squared plus 1. Okay. So now, remember, I want you to find the slope at the point 1, 0. So am I going to simplify this? No. I'm just going to plug this point in. And look how easy it becomes. Because it's 1, right? So 8 plus 1 equals 9. The square root of 9 is 3. So 3 times 3 minus 1 is equal to 2. Minus 1 minus 1 is 0. So since this is 0 here, this entire term, this entire part is 0. Okay, so minus 0 all over 8 times 1, which is 8. 8 plus 1 equals 9. 6 over 9 equals 2/3. That's equal to our slope, m. So we know that the slope is equal to 2/3 and the point is 1, 0. So let's use the point slope formula. Y minus 0 is equal to 2/3 times x minus 1. Y is equal to 2/3 x minus 2/3. Okay. And okay. There you go. There's our this is the right graph. Yeah. Okay. There's our answer. So as you can see, at this point, 1, 0, this is a tangent line. The graph isn't to scale. So the axes are on different scales. That's why it seems kind of steep. But it is, in fact, the slope is, in fact, 2/3. And the equation, the equation of the line is this. And you can see that, yeah, it is right. This is negative 0.5, this is negative 7, this is negative 0.75, So we expect the line to intersect the y-axis at negative 0.66, then it does, around there. Okay. So in that case, we found the tangent line. And remember that the tangent line is a line that touches the graph only at one point. So now there's something called the normal line. And a normal line is a line that's perpendicular to the tangent line at the same point at which we found the tangent line. Okay, and we know that the slope is going to be the negative reciprocal, right? Because the slope of a perpendicular line is a negative line. The slope of a perpendicular line is a negative reciprocal of the line to which the other line is perpendicular to. Anyway, let's do an example. Alright, so here we want to find the line normal to y equals 5x squared plus x minus 1 cubed at the point 1 comma negative 1 comma negative 5. So we first have to find dy over dx, and that's going to be 15, use interchangeable, 15x squared plus x minus 1, 3 minus 1 is equal to 2, and then take the derivative of inside 2x plus 1. Okay, and then plug in this point here. So then that's going to be 15, 1 minus 1 squared times negative 2 plus 1, which is going to equal 15 times negative 1 equals negative 15. So negative 15 is going to equal to, negative 15, ignore that. Negative 15 is equal to the slope of the tangent line. But do we want the slope of the tangent line? No. We want the slope of the normal line, which is a reciprocal. Okay, so it's a reciprocal of, it's a negative reciprocal of this number here. So then, there you go. The negative reciprocal of negative 15 is 1 over 15. 1/15. So, since we have the point here, and we have a slope, we can solve for, we can find the point slope. Using the point slope formula, we can find the equation of the normal line. So that's going to be y plus 5 equals to 1 over 15 x plus 1. And I have the graph here also. Okay, there you go. So, okay, this is the graph of y. Okay, so it's going to be 5 times negative 1, okay, there you go. This is a graph of this equation here. And this is the x and y axis, so this is the actual equation. And we want to find the line that's normal to the graph at negative 1 comma negative 5, this point here, right there. So we expect the tangent line to look something like this, and the normal line is going to be perpendicular at somehow like this, something like that. Okay, and indeed it is. So here's a graph. It's a bit narrower, but you can still see a point here. So that's the point, negative 1 comma negative 5. Let me draw in the axes. Alright, so this is the axes here. graph is this thing here. I drew in a tangent line right there. So the tangent line is this thing here. And then you can see that this is the normal line. And you can see that the normal line is perpendicular to the tangent line, as you would expect. Okay, so that's a normal line. The normal line is the line that's perpendicular to the tangent line at the same point. Okay, and then I have one last thing. Okay. And that thing is so we saw how we could find either the slope of the normal line or of the tangent line given the equation. Now we can also ask the reverse. Okay, so since we know that the slope gives us, since we know that the derivative gives us the slope of a curve, we can also ask at which points on the curve will the tangent line, will its tangent line be parallel to a certain slope or line. Okay, so we can ask at which points on the curve will the tangent line to those points have a certain slope. So the example here is y is equal to 2 cubed plus 3x squared minus 12x plus 24. And what I want to know is at which points on the graph is the tangent line parallel to the x-axis. So I want to find the points at which the tangent line is parallel to the x-axis. And by parallel to x-axis, what does this mean? This means that the slope is going to be 0. So how to do that? Very much the same. First, I have to find its first derivative, because we know that anything to do that deals with slope has to do with the first derivative. So then the first derivative is equal to 6x squared plus 6x minus 12. Okay, now I want to set this equal to what? I have the slope function of the graph here. And I want the points at which the slope is equal to 0. So I'm going to set this equal to 0. And then factor. So 6 times x minus 2 times x plus 1 equals 0. So then we see that at x equals -2 and at x equals 1, the slope is equal to 0. So the question is, find those points. So now we have to actually plug in x into the equation to find a y coordinate. So then, if you do that, it comes out to be like this. So y of -2 is equal to 20, and y of 1 is equal to -7. So at the points -2, 20, and also at the point 1, -7, is a slope going to equal 0, right? So is the slope going to be, so at those points the slope is going to be perfectly horizontal. I'm trying to find a graph here. Here it is. Alright, so what are the points 1 and -2? Okay, so at -2 here, we see that indeed the slope is 0. And at 1, indeed the slope is 1. Okay. There you go. See you next lesson.